Assalamualaikum warahmatullahi wabarakatuh, and good morning to my panels, Dr. Ri and Dr. Akmal. So my name is Muhammad Asrolaizam bin Mahadi. My supervisor is Dr. Nurdiana Azlim bin Othman. My data of my FYP is experimental study of soil resistance for the grounding system based on the type and branches of the road. I will explain about my project first. So basically this project is about the grounding system, and I doing the experimental and then doing the data analysis. So I have three objectives of this project. The first one is to develop a grounding road with the 3 branches and 5 branch roads for the East iron and copper materials. The second one is to determine the soil resistance measurement at the clay soil type. So I'm just using only one type of soil. Before this PSN1, I mentioned three different soil, but unfortunately some issue comes, so I just doing the experiment on the one type of soil. And the third objective is to compare the soil resistance of the standard 3 and 5 branch for the each iron and copper material. So I will move on to the scope. My scope is the first one is I'm just delivered standard 3 and 5 branch roads, and then the data will be the data of soil resistivity will be compared to each other among this road. And the parameter of the road, you can see here the copper road is 0.7 meter, the diameter is 12 mm, and the iron road is 0.7 meters, same with the copper road, and the diameter is different, which is 9.5 to 5 millimeter, equal to 3/8 inch. So the type of the soil that will measure for the soil resistivity is clay soil, and I will suggest the suitable roads based on the result. This is the substitution of the literature review. So as you can see here, I will study about the grounding system, the different soil composition, the road shape toward the soil resistant, and the available road shape design. So the reference and the reference mostly is about among this system, grounding system, soil composition, road shape, and road design. So my flowchart will be like this, which is we start the project which the design of the road, which is the standard 3 and branch of the road, and develop all the design, and then we install all the road at the same location, and then we measure using the ground tester, and then we compare the data with the theoretical. Then the data analysis will be made, and will be conclude the conclusion and end of the experiment. So this is my road design. First I design with the AutoCAD, with the software AutoCAD, and because I design in 3D modeling that can see in many various direction, and then this is the real road that have been developed. So this is the copper one, this is the iron one, and this is a standard type. And the second one is the 3 branches road, which is I will be adding the branch of the standard road and will become 3 branch road, and this for the iron road, as you can see here, the length of the road is 0.7 meter, and the diameter for the copper is 12 millimeters, and the diameter of the iron is 9.525 millimeters. And the last design is fine branch road, which is the copper road. This is the design from the AutoCAD, and this is the real one. The design for AutoCAD for the iron road, and this is the real one. All the 6 design road have a same length, and all the copper road have 12 millimeter diameter, and the iron road have 9.525 millimeter also. And then the location of my experiment is at Parit Kasih. So as you can see here on the Google map, the duration to the Parit Kasih around 30 minutes using car. So this is the site experiment, and this is type of soil, which is a clay soil, that I will measure the soil resistivity. So the procedure that I'm doing the experiment will be explained detailedly in the report, and the winner method I'm using for the experiment. This is a megameter that I've been using for, and the data for the experiment I collect is 7 days, which is 2 times a day that I collect the data, which is at the 12 p.m. and 6 p.m. So I measure the indicate resistance here the value for the megameter, and then the soil resistivity for the each road we will calculate using the formula. And I also record the weather during the data taken. So the data analysis will be made based on the comparison. The first comparison is about the standard road and the standard iron road. So standard copper road and standard copper road and standard iron road. So as you can see here, the copper road have a lower resistivity, which is the iron road have more higher soil resistivity, and the copper road in 7 days have some decrease, but the iron road has some maintain and some increase, which is copper road is better than iron road. And then the comparison between the 3 branch copper road and 3 branch iron road. At the first day, we can see here that the measurement of the soil resistivity for the iron road is lower than the copper road, but after the 3 days, that copper road become more lower than the iron road, which is iron road become increase slowly, and is not good for the grounding system. Okay, the next is the comparison between the 5 branch copper and 5 branch iron road. As you can see here, that a bit different with these 2 type of road. That 5 branch road copper is more better, more lower resistivity, soil resistivity, and as you can see here, the value of the first day for the branch iron road have 55, but only but the copper 5 branch road only 35 to 40 ohm soil resistance. You can see clearly the between this graph that copper 5 branch road is better than the iron 5 branch road. And we move on to the copper material. We compare to all the three type of the road, which is standard 3 branch and the 5 branch. And the copper material, which is the standard one, is more better. We have a decreasing, but the other branches also have decreasing, but the value of the standard road is more low than the other two. Compared to the iron material, that the 3 branches shows that have this low soil resistivity, and the 5 branch have higher the resistivity. So in conclusion, for the iron material, 3 branches more better for the grounding system compared to the standard and the 5 branch roads. And the last comparison is about the surface of the road. So this is the smooth surface for the copper material road, and it's a groove. As you can see here, the surface of the groove road for the iron road, you can see that the copper material for the road, for the smooth as you can see. So the last comparison is about the smooth and between smooth and the groove surface of the road. You can see that this type of the road that we use, they have a different surface. So for this comparison, we can conclude that the smooth surface with the copper material is better than the groove surface with the iron material. So that's the result that I get it from the experimental. And the conclusion that I can make from those results is the standard copper road is the one have lower soil resistivity to improve the grounding system, and the more branches of the road may produce high soil resistivity, and we can prove that the copper material road is better compared to the iron road material. And the recommendation for my project is to improvement on the taking data for the at least amount that can be that have more precise in the data analysis. And I'm suggest that to conduct the experiment in the wide area and suitable area that have no limited when we are scaling the distance between the road. So some error we can prevent some error in measuring data. And the last recommendation is we add some data for the humidity test, which is we can have better analysis about the soil moisture, about the pH value. So that's all from me. I hope you can hear me well. So thank you for listening. Thank you very much.